So the bottom line is that we can test for linear independence by finding the determinant of the matrix. This is because, again, this matrix equation has only the trivial solution if the matrix is invertible. Because if the matrix is invertible, right there is our solution. And the matrix is invertible if and only if its determinant is non-zero. Because in the first, how do we find the inverse of a matrix? We reduce an augmented matrix. We take our matrix, we take the identity matrix, we reduce our matrix to the identity, and what we get over here is the inverse. And if the matrix doesn't reduce to the identity, we're never going to get the inverse. Well, anyhow, so we can test for linear independence by finding the determinant of the matrix where the vectors are columns, okay? Determinant of the matrix for which the vectors are columns. Now, that holds as long as the matrix is square, okay? So this works, and I should qualify this, if you have n vectors of length n. Because if you have n vectors of length n, you will get an n by n matrix. So n could be any number, but you have to have as many vectors as you have elements in the vector, okay? Now, if the matrix isn't square, the matrix you get when you put the vectors in the columns, then this won't work because you can't take the determinant of a matrix unless it's a square matrix. In that case, you consider the augmented matrix and you go through some of the details we looked at. Okay? Now, the augmented matrix might reduce to where you have a row of zeros. That could happen. Yeah. But it can't happen if you have more rows than you have columns. Okay? If you have more rows than columns, then a row of zeros is inevitable. And you need to think about what that means and check that out. It means that you have more equations than you have unknowns. It's overdetermined. You are going to end up with non-trivial solutions. Okay, the final thing I'll say is a basis is a linearly independent set that spans the space. Okay, a basis for a space is a linear set of linearly independent vectors that spans the space. And I've already said kind of what a basis is. And also, every basis has to have the same number of vectors, and this number is the dimension. To test whether a set of vectors is linearly independent, well, that's what we've just been talking about. Okay. So, yeah, there's not much more to say. This just kind of sums up what a basis is, how we test for linear independence. Okay. Now, there's much more to say about basis, and we'll say it, but we need to understand the general concept.